So can we do 55?
Yeah, question number 55.
Yeah.
It's match the column, right?
Yeah.
So wait a minute. Okay. So can you tell me the oxidation state of manganese in MnO2?
+4.
+4. That's good. +4. Whatever you know, you just need to omit it first, okay? Before doing directly one by one. Now, what about the next one? Most stable. Do you know the most stable oxidation state of manganese? Go with the
+2.
step by step. Why it is +2? Yeah, it will. Why it is +2? Yes, I need an answer. Manganese is argon 4s03d5, right? 4s23d5.
Yeah.
So if you are going to remove this will be half filled. So this is your good answer, correct answer. Most stable oxidation state of manganese in oxide. What do you think?
Sir, A is 3, not 2.
Oh, sorry. Yeah, I just forgot to +4 it is, right? MnO2, so it will be like this. Most stable oxidation state of manganese, Mn in oxide. It is +7. If we are going to form this Mn2O7, this will be the most stable oxide in which it has oxidation state of +7. Now, characteristic oxidation of lanthanoid, which is basically +3. It will show always +3, either +1 and +3. So, characteristic oxidation state, it will be +3. Is there any other question?
Sir, next one.
Next one is basically identify A. So you need to go through the reaction only. It's not that much tough. You just need to remember the reaction as well. Identify A to E and also explain the reaction involved. So if we are going to see from CuCO3, you are getting CuO. How you will get CuO? So if you are going to heat CuCO3, what you will get? You will get CuO plus CO2. Yes or
Yeah.
no? So I'm going to write the first reaction. This is the first reaction. Now, if this CuO is going to react with sulfide, what you will get? You will get Cu plus SO2. This will be reduced. Copper will be reduced. Yes or no?
Yeah.
So this will copper will be your A. That means A is your copper. Now, this copper is going to react with HNO3. And when the reaction takes place in concentrated HNO3 with copper, it will be oxidized like CuNO3 whole twice copper nitrate plus 2NO plus H2 for the balancing. I just wrote it. Now, if you are going to see the main product, B will be your this Cu plus 2. This is the main product, CuNO3 whole twice. So this will be, I'm going to take Cu plus 2 since it is in aqueous. So copper nitrate will be in Cu plus 2. Is that clear? So B is your Cu plus 2. Are you getting my point?
Yeah.
Now, if Cu plus 2 is going to react with NH3, which is a very good ligand, what you will get? You will get CuNH3 whole 4 raised to the power plus 2. Because NH3 is a very good ligand. You have studied this in P block element. Are you getting my point?
Yeah.
Now, after getting this is your C. Now come to this point. CaOH whole twice. Okay, if you are going to, we need to think about this. Okay, so after heating CuCO3, you got CuO, this is your CuO, and CO2. So D is basically your CO2. So if you are going to react CaOH whole twice with carbon dioxide, then you will be getting calcium carbonate, which will be milky. This reaction you have studied it in class 11 S block element, when calcium hydroxide select line will be reacting with carbon dioxide, then calcium carbonate will form. Is that clear?
Yeah.
Now it's calcium carbonate. Oh, you can see the rest is salt, right? Only we need to, A is your Cu, B is your Cu plus 2, C is your CuNH3 whole 4. That means tetramine copper 2. D is your CO2 and then E is your CaCO3. So you have to remember the reaction as well. Is there any other?
So I'll write this down 1 minute.
What you just said?
I'll write this down.
Okay, please do it. Let me know when you are done writing with this. Are you done with this?
Yes.
Is there any other doubt in D and F block?
Next one, sir.
Yeah, the question number 65, are you asking?
Yeah.
Okay, so if you're going to, if you have studied NCRT, there is a term that is chromite ore, and that is fused with sodium carbonate. Basically, this is the preparation of potassium dichromate. Potassium dichromate, and this ore is basically iron, FeCr2O4. This is the ore. Let me just erase the above part. So if you look at the first preparation of potassium dichromate, you will find that there is a process, or there is some compound that is chromite ore. This is your A, fused with sodium carbonate, that means Na2CO3. And then in free excess of air and the product is dissolved in a yellow solution of compound B is formed. So now wait a minute. Product is dissolved in water. A yellow solution of compound B is formed. Okay. So if you are going to react this with Na2CO3, you will be getting Na2Cr2O7. No. This will be chromate only. You will be getting CrO4, which is sodium chromate, and which is yellow in color. So this is your B. So after getting B, after treatment of this yellow solution with the sulfuric acid, if you are going to react this with sulfuric acid, then what you will be getting? You will be getting sodium dichromate. That means Na2Cr2O7 along with sodium plus H2O. And after getting this Cr2O7, that means dichromate, sodium dichromate, uh, when compound C is treated with KCl. Now you are going to react with this KCl to KCl, then this sodium will be replaced by potassium K2Cr2O7. And this is your main product B. So this is your D, and this was your A, and this is your B, and this is your C. Isn't it easy? This is inorganic and organic is all from NCRT. And especially I will suggest you to read each and every line of inorganic chemistry. It will help you to achieve your 100% in board as well as competitive exams.
Yes.
Is there any other? Just check it out.
1 minute.
And let me know. Okay, take your time. Just let me know if you have any doubt, or you can solve it. The questions that I have given from D block element is very important, and it is completely based upon NCERT. Some from exemplar, some from other sites, and mostly from the previous year's question. So, Firaz, can I ask you a question? When is your what is on which day your chemistry paper is?
So 28.
6,
28.
28. Oh, okay.
Yeah.
That means basically in India here it's also on 28. Same paper will be there, or different paper comes.
Usually they send 3 sets. So can be anyone.
Okay, got it. So can I share the next chapter, that is haloalkanes? Oh, you are still checking it.
20 is B and D, right?
Let me just check it. Where is question number 20?
It was the next
Page.
one, 60 after 60.
Oh, after 65. Yeah, which of the following? Yeah, heterolaptic, you know that. Heterolaptic, that means B and D. This is homolaptic, right? Same ligands.
Yeah.
Is there any other?
The 31st, it's due to CN and H2O.
Yeah, you have to check it. You know that a strong field ligand in our orbital complex pairing will take place, I think. And if there will be any unpaired electron, 1.74, that means here one electron be unpaired, and here almost 5 electrons will be unpaired. I think so. If you look at it.
So I go to the next page.
Next page is like this.
The match the following.
Yeah, you want me to do this? 38.
Yeah.
Okay. COCN whole force. First of all, cobalt and having coordination number 4. So it can have 2 sp3 or dsp2. One is the possibility, but CN is there. That means a strong field ligand. So dsp2. So it will be dsp2. And also the number of unpaired electron you need to tell. So you just need to do the electronic configuration as well. I think it will be right. Are you getting my point? Yes or no? Or should I explain it?
Cobalt.
See, if you are going to calculate the oxidation state, you will get CO plus 2, right? And after doing the configuration, this will be the configuration, yes or no?
Yeah.
Now, as you know that 3D7, that means 3D7 will be 1, 2, 3, 4, 5. Now I'm going to fill the electron according to this. Full half filled 1, 2, 3, 4, and then 5, then 6, then 7. Okay. So as you know, CN is a very good, very strong ligand. So it will pair up, right? If it will pair up, what you will see? You will see that this is already paired, this is already paired, and this will be paired, and one electron will be here. So there is vacant orbital in D, and 4s is also vacant, and 4p will also be there, which is vacant. Now, how many CN you have to pair up or make a coordinate bond? You have 4 CN. So the first CN minus will come and go here. The second CN will go here, and the rest 2 in this. So you can see for the overlapping or making coordinate bond, you used 1D, 1S, 2P, so DSP2, and 1 electron unpaired. So it is right answer. Is that clear?
Yeah.
So in CrH2O whole 6, H2O is a weak ligand, so the pairing will not take place, right? So if pairing will not take place, CN coordination number 6, it can have sp3d2 and it can have d2sp3. Since pairing will not take place, so sp3d2, yes or no? And here cobalt will have, chromium will have oxidation state +3. That means argon 4s0, 3d what? 3d3, yes or no?
Yes.
So as you can see, 3 unpaired electron is there. 3 unpaired electron is there. So D2sp3. So it will have 3 unpaired electron and sp3d2. So it will come in 4. In the same way, you can do the rest. NiNH3, you can see NH3 is a strong ligand. So there will be pairing up. And if you are going for the configuration, you can see the configuration will be 4s0 3d8. For 3d8, you know that 1 2 3 and then 4. 1 2 3 4 5 6 7 8. And this will be, there will be no pairing up, because if there will be pairing up, only one vacant orbital will be there. So you will start filling from 4s, 4p, 4d. So it will be sp3d, sp3d2, and the unpaired electron will be basically, how much unpaired electron will be?
2.
There. Oh, then there will be some mistakes. Wait a minute. NiNH3, right? Oh, I did a mistake in this. Chromium pairing will not take place. Okay, sorry. D2sp3 it will be. So I just did some mistake. One will be like this, D2sp3, right? A will come in here, D2sp3, and this will be like this, sp3d. Yes. And the rest you can do. Yes or no? Or should I explain it?
Yeah.
Because
Yeah.
should I explain?
Okay.
Okay. So will you be able to do the rest, or should I explain?
39.
39, you need to take care of this. Only the, I think, only the student is stuck in this. You know how to do this if you know the rule and regulation. But in this, I'm gonna tell you. Wait a minute. D will be, what do you think? There is two coordinate compounds, so it will be coordination. Yes or no?
Coordination.
Coordination
Cis will be
isomerism.
geometrical.
Oh, wait a minute. Cis, where is
B.
cis? B will be, no, wait a minute, please. B. Why B will be geometrical? I'll let you know. First, need to do the coordination, and then, what about A? Can you tell me? It is like Ma4B2. Isn't it geometrical? Ma4B2. Just let me know if you have Cl here and NH3 here. So with respect to Cl, can't you say that this is your trans? Yes or no? Have you seen this?
Yeah.
Now come to the next. It is already written that it is cis. So cis platin, or you can see COEN whole twice. That means En is like this.
Optical.
And so it is optical. Yes, this is what I want to say. Now you can see NO2 and Cl. This will be ionization. Yeah. Is there any other? Please do.
What is NCS here?
NCS is thiocyanide. You know, CN is cyanide. CN is what? If there will be S, that means thiocyanide. Is that clear? Like OH is alcohol. If you are going to put SH, that will be thioalcohol. So NCS is CNS. Sorry, SCN is thiocyanide, or either you can write NCS, because it is what we call a special type of ligand, ambidentate ligand. Is that clear?
Yeah.
Okay. Is there anything that I should explain? what is the answer for this? Just let me tell you the answer. So A comes here because there will be negative and there will be S. So 3 minus 2. So it will be plus 3. Now there is 0, minus 2, minus 2, minus 4. It will be like this. B will come to 1. And S2O3 minus 2 is there, minus 6 it will be, and it will be plus 2. So it will be like this, and it will be 0.
The problem is like I'm forgetting the oxidation numbers.
No,
So I'm
what
not
you
able
need
to
to
calculate.
do. Okay, okay. See, I also don't revise at all, but practice. It's all about practice. See, some of them you already know. If you don't know SCN, but you know NCS, right? CN minus, SCN minus. So there will be negative charge. It is ambident ligand, so it will be negative. NH3, some of the ligands you have to take care of that. NH3 is neutral, so it will be 0. SO3 minus 2, you are learning it from your childhood. Sulfate, sulfide. Aren't you getting my point? And there will be x that
Yeah.
will be equal to 0. So it will be x minus 3 that will be equal to 0. So x will be equal to plus 3. Now come to the next, cobalt X, NH3, 0. You have to take care of the one which is having neutral. Cl2, 1 Cl has minus 1, 2 Cl will have minus 2. SO4, that is minus 2, that will be equal to 0. To make your oxidation states type questions stronger, you need to deal with NCRT as well. The question that is given for nomenclature as well as calculating oxidation number, you are going to do that and it will be enough for you. Now S2O3 minus 2, that is sulfurous acid, that will be basically, there will be negative charge, and minus 2 into thrice, that means minus 6, and there will be X, and you can see 1 Na has plus 1, so 4 Na will have plus 4, so it will be X is equal to plus. CO is neutral ligand, so it will be 0. Done. Are you there?
Yes.
Should I share the next?
Yeah.
Okay. So I also shared in on WhatsApp. I'll be back within a few minutes. Please do it. Firaz, are you able to solve this?
Yes, sir.
Firaz, are you done with all this?
Last page, sir.
Okay.
Have a look at 60th one.
Yes, Firaz.
60th one. 60.
16. Wait
60.
a minute. I'll just explain.
60.
60.
Yeah.
Okay. Okay, wait a minute. Okay. 60 question. Where it is. A hydrocarbon of molecular mass 72 gram per mole, right? Gives a single monochloro derivative and two dichloro derivative of okay. So hydrocarbon. Okay. Firas,
Yeah.
can you think of a hydrocarbon which will have 72 gram per mole? You just have to think by yourself. Can we take
Pentane.
pentane? Pentane, that's a good answer. But you need to take the isomerism of pentane, in which we will get two dichloro derivatives on single monochloro derivative. So can we write the pentane as this? This will have 72 gram per mole. Yes or no?
Neopentane, right?
Yeah, neopentane. If you are going to do react with HNO, you will be getting this product, right? This is the monochloro derivative. Yes or no?
Yeah.
And it has been said that and two dichloro derivative. Again, if you are going to do, what you will get? Two chlorine here. So this is the answer. Have you got the answer? Or either you can write chlorine here and chlorine here, same. Two dichloro. This is the dichloro. This is dichloro. Have you got it, or should I explain it more?
So can you write it in structure instead of this branch? Like,
Actually, this branch or bond line structural formula is too easy to write. Just you need to draw. That's why I use it, but no problem. See, for monochloro derivative, can I write this? So first you are going to react this with Cl2 in the presence of HNO. You will be getting CH3C, CH2Cl, and then CH3CH3. This is your monochloro derivative. And for dichloro derivative, either you can add chlorine here, dichloro, that means you need to add two chlorine. Either you can do this, dichloro it is also, or either you can stick two chlorine to a single carbon. So this will be your 1,3 dichloropropane, or sorry, methyl and propane, and this is your 1,1 dichloro. Are you getting my point?
yeah.
Is there any other?
No.
What about the next one? Next chapter?
Alcohol.
Okay. So the next chapter is alcohol. Okay, thank you for today.
So I'm doing this. I will send in a while.
What are you saying? I'm not getting it.
I'm doing this. I will send it.
I'm doing the
I'm doing this paper, like just some more questions I will send.
okay. Please send it to me.